Okay, we are going to learn about naming, measuring, and classifying angles in this video. So if you would please take a moment to find a pencil. Remember, you want to use a pencil for your notes, and also please write in the learning target on your note sheet as well. I've noticed a few of you not filling that part in, but you do need to write down what the objective is. The whole idea of this video is that you can name, measure, and classify angles. And there are some important vocabulary terms that I'd like you to fill in, so if you need to stop the video, go ahead and do that. But I'm going to go ahead and go through each of these. So we do have a new symbol. The new symbol is for the word angle. And so we're just going to use, it almost looks like a less than sign, but a less than sign would be more like this, and angle generally has a more straight or flat base to it. So it's kind of an angled line with a flat base at the bottom. So that symbol right there, and if you notice a little bit down on the notes here, the name of the angle AOB in the diagram is symbolized with the little symbol like I just showed you. So an angle consists of two different rays at the same endpoint. The rays are the sides of the angle and the endpoint is the vertex. Okay, so the vertex is the actual point of the angle. So if I have an angle that looks like this, I have a couple of rays, okay, and the point that it comes to is called the vertex. So this is what we're referring to when we're talking about the vertex. And the sides are just rays, okay, so this is a side here of the angle, and this is a side of the angle as well. An acute angle has measure greater than 0 and less than 90, and that's going to be a small one, so kind of like if you think of a cute little angle, so this is small. A right angle is going to be exactly 90, so that's like the letter L, straight up and down letter L. And obtuse is going to be larger than 90 but less than 180. And then a straight angle is equal to 180. So this is also just kind of like a line. So a straight angle is exactly 180 degrees, and it's kind of like a line. Two angles are congruent angles if they have the same measure. You guys might remember that the symbol for congruent is the equal sign with a squiggly over it. So I could have just written this symbol, congruent angles. Those are the ones that have the same measure. And an angle bisector is a ray that divides an angle into two angles that are congruent. So, for instance, if we look at this angle that I already drew, if I wanted to say that I was bisecting this angle, I could make another ray and then mark that this part here is congruent to this part here. So there's some special little markings that you'll see as we go on that mean that the angles are congruent as well. So similar to how we said that some segments were congruent, we also have a way to say that angles are congruent. All right, let's go on here to postulate 3, the protractor postulate. Perhaps you've used a protractor before, and if you take a look at this diagram here, we have an angle AOB, and it is about, we can go ahead and measure how big this angle is. Notice that the bottom, this ray right here is laying on the line that's on the protractor, and then we're kind of matching up this ray right here to one of the numbers. Now there's two sets of numbers. Here we have where it starts at 180 and goes around to 0. Okay, the 0 is over here. But on this part of the protractor, we start at 0 and we go all the way around to 180. So we have to decide which one is this, which kind of angle is this. This actually is an obtuse angle. Okay, so if we look at the definition of obtuse, obtuse just means that it's larger than 90 but less than 180. And we see 90 right here on our protractor. So the angle that we want to look at, or the numbers that we want to look at, are these bottom numbers, not the top numbers. So we're not looking at these because, of course, 90, 100, 110, 120, 130, 140 is where we see that this angle ends. So because the angle is obtuse, we just know that because it's larger than 90, these are the sets of numbers that we're going to be looking at, the numbers that are larger here. So in this case, angle AOB is equal to 140 degrees. And basically it says on the protractor postulate that we're just laying this ray on the protractor and reading the number, the coordinate that goes with that. Sort of like when we measure something with a ruler, we're reading the number that goes with that. Okay, and let's move on to postulate 4. Angle addition postulate. This angle addition postulate states that we can add two angles together, the measure of those angles, and that's going to equal the larger angle. So if point P is in the interior of an angle called RST, and let's go ahead and draw a picture of this. We'll say that this is going to be our angle RST, and we really haven't gotten to naming angles yet. We're going to get to that in example number 1. But the middle letter, S, is always going to be our vertex. And then the other letters, R, which is the first letter, is going to be on the ray, and T is going to be on the ray. So if we say that point P is somewhere in the middle or in the interior space is going to be anywhere inside the angle this way, we're going to put point P in there. So let's say point P is right here, anywhere inside really, and then we connect the vertex to that point. Now we have a new ray. Well, we can add together this angle RSP and add it to PST, and it's going to equal the big angle RST. Okay, so if we add this angle, I'll just put a 1 in it, plus this angle here, it's going to equal the large angle on the outside. And you can see that because, like, if you had a piece of pizza, two pieces of pizza laying next to each other, if you took one slice here and another slice here, you were really taking the entire two slices, weren't you? So we're just adding together the angle addition postulate. I bet some of you think I might bring pizza in, just as I mentioned that licorice was a way for us to bisect things and find midpoints. We brought licorice into class. I wonder if we can get enough pizza for everybody. Well, let's go ahead and finish our angle addition postulate. So if angle RST, okay, that's the big angle that we just made, we could add together RSP and PST, and that's going to equal the big angle like this. So two smaller angles are going to be equal to the big angle there. One last thing I should probably mention is the name of angles that are next to each other. Anything that are next to each other, any two things that are next to each other are considered adjacent. Okay, so that's another word that in geometry we're going to be using a lot. And the word adjacent just means next to. So angle 1 here is next to or adjacent to angle 2. All right, we're going to go ahead and look at example number 1, how to name angles, and this is really important, so please pay careful attention here. We have an angle drawn over here, and we could name it 3 different ways. Okay, so this angle could be named by its vertex, and the vertex of this angle is B. So we could call this angle B because it has 2 rays going into that one point, and we could just call it angle B. If we also could name this ABC because we could name it from the 2 points that are outside, but point B, the vertex itself has to be the middle letter. Now the third way that we could name this angle is going to be CBA. Okay, so if I refer to this angle any 3 of these different ways, I would be referring to this angle, the angle that has these 2 rays and the point B as its vertex. Okay, the sides of these angles are going to be BA, the ray that starts at the vertex and goes out toward this point, and also BC. Remember, when we name rays, we have to start at the end point. We can't start at the other end where the arrow is. Okay, so we have 2 sides as well as a vertex, and that forms the angle. Now I do want to mention that if I had another point over here, okay, this would be a completely different angle, which let's say it's a BD, okay? So now I cannot any longer refer to this as angle B because I would be wondering, am I talking about this angle B or am I talking about this angle B? So if we have a third ray coming off of the angle, we can now no longer just use the one letter. The only time that we can use one letter is if there's only 2 rays going into that specific point. If there's a third one, that immediately eliminates the point that we can call this by one letter anymore. Then we have to start using 3 letters to name the angle. So that's something that we're going to be working on. That's often something that students have some trouble with. Please turn your paper over. You're going to be working on these 2 practice problems here for practice on your own. So number 1 and number 2, I'd like you to give 3 names for the angle, name the vertex of the angle, and then also name the sides. Be really careful. Remember, these are going to be rays, and you want to make sure you start at the end point, not at the point that is at the other end where the arrow is. All right, and then I'm going to go ahead and do example 2, which is measure and classify angles. So if we take a look at the diagram here, it looks like we have a couple of adjacent angles. Okay, we have adjacent angles, and those are going to be angles ABD, right? This is ABD, and DBC. Okay, so these angles are next to each other. That's what we mean by adjacent, and they form angle ABC, this large angle out here. Okay, the 2 of them added together kind of equal ABC. So we need to find the measure of angle ABC, but we are given the measure of angle ABD and DBC. So they wrote it on the diagram, which is nice. And if we just add those 2 numbers together, we're going to find the measure of angle ABC. So 90 plus 45 equals 135 degrees. And so that's the measure of angle ABC. One other little detail here, this little tiny m stands for the words measure of. Okay, so the little tiny m, when you see that, always means measure of, and then you can see the symbol for the angle there. All right, and we are to classify each angle as acute, right, obtuse, or straight, and there are 3 angles here. Notice that I numbered 1 and 2. And then, of course, the third angle is going to be angle ABC. Okay, and we already told the measure of angle ABC, and it's 135 degrees. So that falls in the obtuse category because it's larger than 90 but less than 180. Angle 1 that I have numbered here is also called angle ABD. And we need to tell whether that's right, acute, obtuse, or straight. And it looks like it's equal to 90. So that's going to be a right angle. And then finally we have angle DBC that I also have numbered as number 2 angle. And that is less than 90. It's 45 degrees. So that's going to be an acute angle. A cute little angle. All right, well, what you're going to do then is you're going to take care of these 2 practice problems before you come to class, please. You're going to practice problem number 3 and number 4. So you want to add together the angles that they're asking you about and find the measure of those angles. Now be careful in number 4. It's a little bit tricky. Notice that they're giving you a straight angle, 180 degrees. ABC is a 180 degree angle. And then they tell you that this angle, ABD, is 60. So how much is this one if the entire angle is 180? So that's a little bit tricky. Be careful on that. Make sure that you ask questions in class when you come to class tomorrow. So if you have space on your paper, if there was something that you did not understand, please make sure you take a note to yourself so that you have time in class tomorrow to ask questions. Have a good day.